In this session, I'm going to look at making different kinds of basic financial calculations using R. We are going to look at the basic initial concepts like time value of money, especially, right? Where we talk about present values, future values, annuities, etc. So NPV, IRR, different kinds of basic financial calculations, and how do I use the different kinds of R functions that are available to do all these calculations. So that's the major objective of this session. So we would have some amount of discussion regarding the interest rates, where we talk about the normal compounding of the interest rates, and we would also talk about the discount rate. What do we mean by interest rate? What do we mean by discount rate? How do I convert interest rate to a discount rate and vice versa? Then we also bring in the nominal as well as real rates of interest. The nominal rates of interest primarily, especially when we are talking about compounding frequencies, multiple compounding frequencies are there, right? Let's say the compounding happens twice a year or quarterly. Then what is the nominal rate of interest and what is the real rate of interest in that case? How do I convert from the nominal rate to a real rate and vice versa? Do I have any kind of R functions that are directly available for converting from a nominal rate to a real rate? The same logic holds true for discounts as well, not just for interest, even for discount. Do I have some kind of a function which can convert nominal rate of discount to a real rate and vice versa? Especially if the compounding happens mthly every year. Mthly means every quarter, every 6 months, every month, whatever it is. Then we would move on to understand another set of important concepts which we use for evaluating a lot of project decisions, wherein we would be talking about the NPV and IRR, net present value, and internal rate of return. Again, we'll see how we can use the R functions for accomplishing the same. Then we are bringing in the annuities. Annuities, we'll discuss about them, right? Generally, we are talking about equal installments to be paid at equal intervals of time. So those are typically considered as annuities. So how do I really get into finding out the values of the annuities, both the present value as well as the future value, otherwise called as accumulated value? So we'll be looking at that particular stuff. Now, as I said, in the definition of the annuities, we are talking about equal amounts to be paid at equal installments, equal intervals of time. But in some cases, that amount could be either increasing or decreasing arithmetically. So that those kind of annuities are being called as arithmetically increasing or decreasing annuities. So how do I find the present value or future value of those kind of arithmetically increasing or decreasing annuities? That's one more aspect that we need to look at. Similarly, in some cases, the amounts would be growing not in an arithmetic progression, but in a geometric progression, right? Probably 100, it would be increased by, let's say, 10%, 110, 121, 133.2, so on. So the annuity is growing at a geometric progression. If it is growing at arithmetic progression, 100, 110, 120, 130. So this is what it is growing in an arithmetic progression, the amounts. In this case, the amounts are growing in a geometric progression. So if they are growing in a geometric progression, how do I compute the present value or the future value? So those kind of scenarios also we are going to look at. Then the other aspect that comes in is deferred annuities, where the annuity is not starting immediately, but it is starting after a couple of years. So annuity itself is nothing but it's an equal installment in equal intervals of time. Now instead of starting immediately in the current year period itself, it will start probably a couple of years later. If that's the case, how do I compute the present value or the future value of that particular annuity? So we are bringing in those kind of calculations as well. Then once we have a conceptual understanding of all these things, we want to apply all these concepts to the regular financial scenarios in the real world, where I want to do the pricing of a bond. So I'll take a quick example to do the price of the bond. Then loan amortization. I want to take a loan. I want to compute the EMI, or not just the EMI. I want to make a complete schedule of the payments. So how do I do that in R? What kind of functions are available for me to accomplish such kind of stuff we are going to look at. And in a bond, one of the ways we talk about the risk of the bond is through duration and convexity. So these are the measures of assessing the riskiness of a series of cash flows. So how do I really assess the riskiness of this particular series of cash flows using duration and convexity? So these are some of the things that we want to look at as a part of this session. So let's get into one by one. Getting started with the interest rates. We know financial mathematics per se, when we talk about the word financial mathematics, we are dealing with time value of money. A dollar today is much worthy compared to a dollar that I receive in the future, let's say after 1 year. The same $1. Because the $1 that I am having today, I can invest it for 1 year at some interest rate, and I will get something more than 1 at the end of 1 year. So which is a clear indication that with the passage of time, the money is increasing in value. That is what we are calling as the time value of money. So as a simple representation, if I am talking about an amount X, I have invested it for T years, and every year my effective rate of interest is I. We use the word effective rate of interest. In effect, every year I am getting an interest rate of I. That is what I am calling as effective rate of interest. So if that is the case, with the help of compounding that is happening, I am going to receive x into 1 plus I to the power t based on the compound interest formula, right? So this is a very simple calculation. If I have deposited x amount for t number of years, and per year the effective rate of interest is I, I'm going to receive x into 1 plus I to the power t at the end of t years. So this I is very important for us because we are dealing with interest rates. This I is called effective rate of interest, which is as good as saying, so if I'm talking about this as one single period, let's say in this case take it as an year. So I am depositing one. I'm depositing 1 at the beginning of the period. How much will it become at the end of the period? Let's say at the end of the period it becomes 1 plus I. Now this I is what we are calling as the excess is I. This I is what we are calling as effective rate of interest. So that one single unit, when I am investing at the beginning of the period, what will it become at the end of the period? That excess that I am getting during the period is what is typically called as effective rate of interest. Right? 1 becoming 1 plus I at the end of the period is what is my effective rate of interest. So the interest here is I.